So, okay, then I will start presenting. I hope you can see the screen.
Yes, sir.
Yeah. So your this course is about speech processing. So I don't need to tell you much, I guess, how important speech as a signal is. So what I will do before I go into the depths of speech processing and discuss with your syllabus, do one thing. Just a minute. Before you, yes. So uh, in your chat, I have given you this link. You are getting the link.
Yes,
I
sir.
Yes,
hope
sir.
you. Yeah. If you get the link, no need to unmute yourself. Just type Y. Okay. Just type Y if you got the link, and then watch it. This is a 6 minute clip. Okay. So it's from a series. It's a Netflix series many years ago. So it gives a very good representation of the importance of speech signals. So let's start with that. Then I will go ahead with other topics and how we'll proceed in this course. So I will also watch along with you. You can go ahead and click on that link and watch it. It's a 6 minute clip. If you are done, please type Y. Yes. So I hope it was kind of, we all like to think and fantasize ourselves in whatever work we do. Think so. This is a good way of romanticizing about how important speech is. But speech, undoubtedly, along with, I would say, uh, AI in medicine, AI in speech and speech processing is the topmost of technology. There is nothing currently, and it has been historically as well, since the days when the telephone was invented for communication, long distance communication. Speech has been the forefront of technology, and it seems that it will be, at least in the near future, no doubt about it. How machines are able to produce speech, which is called human machine interaction in the field of speech processing, that will be one of the most important technologies, both in civil and intelligence domains. So let's get back to our basic slides, what we will be doing. So the processing course that we'll be taking in this, it does have some prerequisites. It's written none in your course curriculum, but it does have prerequisites. So I hope you are at least comfortable with signals and systems. Signals and systems or basic signal processing is a must. And if you are not, you will have to devote some time to go back and revise and become comfortable with basic signal processing or signals and systems. So why? Because in signal processing is like a triangle. We have signal processing, but to do signal processing, we have to understand the physical properties, physics or the source of the signal, how it is produced or how it is interpreted. We need to be able to mathematically formulate that, and then we need to program or code effectively. We have to find out effective means of programming the mathematics. These three domains make up signal processing. In the case of speech signal, it is a very complex system, both production and perception. Very important. You need production, you need to know about the production, how it is produced, and also you need to know about perception, how your human ear or the entire brain is involved in this process actually. But let's say on the human ear, how it is able to perceive sounds. So both these aspects, production and perception, are incredibly important, and we have to mathematically find some mathematical formulation of understanding them, and then we have to code it. Now this mathematical formulation is not possible without understanding the basics of signal processing. What is a linear system? How do you represent signals in the frequency domain? What is Z transform? And even the continuous time things, that Laplace transform, continuous Fourier transform, and so on and so forth. So I will cover in the first few lectures briefly the main things that we will be touching upon, main signal processing concepts. But you will have to devote some time from yourself in case you are not comfortable, because otherwise it will be very difficult. So this is a cutting edge field of research, speech signal processing. So you will need to give some time. Ideally, speech processing courses should have two components. One is simple speech processing, which we call domain knowledge. That means you need to know the physics and mathematics. And then we have what is called speech technology. That ideally it should be covered in two parts. In speech technology, we'll cover all the programming aspects. Here also we'll do some amount of, we'll show, but in speech technology, mainly from machine learning point of view, and some statistical signal processing, from both those points of view, we emphasize those things called, it's called speech technology or voice technology, voice slash speech technology. So this is an in absolute zenith of current research and technological development, both in industry and also in academics. So before I proceed further, I forgot to this one. I hope you are able to hear. If you are able to hear me properly, type Y in the comments. Yes, okay. So I will proceed. So let's look at the syllabus, because this is an introductory lecture. Let's look at the syllabus. So what are we going to cover? Speech fundamentals. It means covering how speech is produced, and the classification of speech sounds. So, what English, unlike our Indian languages, most of our Indian language is not phonetically consistent. What does that mean? It means that the word "c," for example, sometimes in some context will sound like "k." The word E will sometimes sound like A. So whatever the letters, when you pronounce them individually and when you include them in continuous sentences, one continuous speech, they are not the same. That's why it's one of the more difficult language. This is also true for all other Latin languages, like derived from Latin or relatives of Latin. All this French, Spanish, everything, they are even much more difficult. So there are classification of speech sounds. So English has got 26 alphabets, 5 are vowels. Just a minute. Uh, just a minute. So 5 are vowels, and the rest are consonants. So vowels have, if you analyze uh, the characteristics, if you record a vowel sound A, O, U, if you record it and just simply see its frequency domain characteristics, you easily visualize how different they are from consonants, the rest of the alphabets. But as I said, the number of individual sounds in English is much more than the letters give. Actually, there are around 40 to 50 individual sounds in English. Different languages have different this one and a different number of individual sounds. We call them phonemes. So each of them or different types of sounds, we can categorize them, classify them into different groups, have different properties. Mainly, we can broadly classify them into something called voiced or unvoiced. What they are, we'll learn in depth. We'll understand them as the course proceeds. So, we have to learn the classification of speech sounds, and we'll go through the system, a mathematical model that explains how these sounds are produced. You see, what happens is speech is produced only when we exhale. We cannot talk when we are inhaling. So air is pumped out from the lungs through a long tube. So you must have heard the term pitch, particularly singers use this pitch. So pitch is something related to uh, an equipment or a pair of we call we call it vocal folds or vocal cords, two ligaments basically. I will show you diagrams and video recordings of how it looks like that vibrate, and the rate at which vibrates determines your speech and changes your speech pattern and how you speak. Lots of things are there. So from those vocal cords, the long pipe that you have, twisted pipe that ends in your mouth, the lips, the tongue, and everything, they form a complicated system of tubes. We'll learn about what is called the source filter model of speech production. So, having gone that, we'll need this digital signal processing. I have told you, we'll cover some concepts regarding that. Then we'll go for speech analysis, means what we have in the end is the speech signal itself. The speech signal itself, it is a pressure vibration over time. As we release, as the speech comes out from our lips, it is nothing but change in pressure in the air, just uh, adjacent to it. And then that travels, that changes over time to give us different sounds which combine together to form some understandable speech in a particular language. So this, of course, We use a microphone to convert it into an electrical signal. Why electrical? Because once you make it electrical, then you can process it through a machine, particularly a digital computer. We can also use it for communication easily, storing easily, and lots of things we can do once we convert it into electrical form. You know, electricity and magnetism are intertwined. That means you can also put it on a carrier and send it across many, many million miles, many, many thousands of kilometers. So to be used as mobile communication. So that's the reason. So more or less this pressure signal that we get, which we call as speech, will be converted into an electrical signal, and then we'll analyze this electrical signal to find out its different characters. We will find out what is source characteristics are. For example, every person's voice has its signature, his or her signature. Every person's voice has identity. Just like your fingerprints have an identity, your voice carries your identity. That is why speech is a very important tool for forensic investigation. It is not a perfect tool, it's a very difficult tool to analyze compared to others. But because it is so easily recorded, it can be so easily collected, it is a very important forensic and intelligence tool. So you can just imagine, we just saw a video, 6 minute long video. It's very easy to collect speech. So that's how people in intelligence agencies record or track people down, and we have to analyze that speech. Hope it is able to give us some clues as to who the fugitive is or who the target person is who is speaking. It may not be perfect all the time because there are a lot of issues, background noises there, all those sorts of things are there, which gives rise to many different uh, applications or domains or tasks required to achieve a application in speech processing. Many subtasks are there, but you can see because of the easy way to convey your message, because of the easy way to store and collect information, speech is always going to be one of the key aspects of research and technology, as I've told before. So anyhow, so once you get the speech signal, now we need to, it is available for all sorts of analysis. So I talked about this identity. Every speech also carries information about the person's health. That field of research is called voice pathology, voice pathology detection, or voice pathology analysis. You can get information about the person's age, which is indirectly related to identity. You can get information about the person's accent, of course, that also indirectly is related to this person's identity. So, lot of small things you can get from speech signal, but all this information that is embedded in that speech signal, it also makes it complicated to individually collect certain information. But nevertheless, all those information are there, and that's why all sorts of applications come up in speech processing, from emotion recognition, voice pathology, health, biomedical signal processing, to speaker identification, or which is finding out who spoke, which is indirectly related or dependent on this accent and uh, uh, what is called age and age detection and all those things. Then we have the most famous one, speech recognition. So I am sure you have seen Amazon Alexa. I am sure you have seen Amazon Alexa. You have seen Google Home, at least in image in internet. If you, obviously not many of us use those devices, but Still, I am sure you are aware of that. What are the, or even your mobile phone, you just speak on your mobile phone and it converts it. If somebody is not good, or he is not very educated or literate, rather not educated but literate, he can just use his mother tongue. It will convert it into text, and then the text is processed by on a server in the internet, and whatever information is he needs is fed back. And even that information that he needs, it can be again converted back to speech if he doesn't understand or know how to read and how to write properly, read and write properly. So the first task, converting your speech to text, is called speech recognition. The second task, converting your text to speech, is called text to speech or TTS technology. So both of these are very important, and they are at the forefront of research at the moment. You are obviously aware of this because all your mobile phones support at least the front first one, ASR, automatic speech recognition. You can speak on your Google Voice. You can use and get the information you need. So, uh, so coming back to again uh, analysis of speech. So all this is possible through processing of the speech signal in a very intelligent manner. We have machine learning techniques which will take care of the programming part, as I said, the programming part. But for machine learning to work or AI to work, you also have to give it some intelligent features. It is not enough that you just simply give a speech signal and the machine will, you think that the machine learning algorithm will figure it out by itself. It doesn't happen that way. Though we are trying to move towards that direction, but it's far away from that. We need some domain knowledge. We need to understand how the speech was produced, or how the human ear understands speech, so that we can then use that speech signal, process it, use some processing techniques, some algorithms, some ways of processing it, so we can convert it into some few features, which we can then feed to the machine learning algorithm. So speech analysis is based on finding those features, finding those important characteristics of the speech signal in terms of a few numbers from an entire speech signal. Let's say just a 1 second speech. I will assume you know what sampling rate. Let's say that's sampling rate is 8 kilohertz. That means 8,000 hertz. 8,000 hertz means in one speech signal there is 8,000 samples. 1 second speech signal, there is 8,000 samples. Why will a machine, if I process every second of speech, if it's 8,000 samples, the machines, no matter how good they are, means it will take so much time. There is a lot of redundant information. You need to concentrate or find out, extract important information from the speech signal based on your application. So this is where all this signal processing algorithms techniques come. We'll learn about LPC, we'll learn about MFCC. Those two are the main, absolutely important things we'll have to learn. We'll learn about capstral analysis. We'll learn about dynamic time warping. So this is how we'll proceed with speech analysis. And then once we do that, then the rest of it We have speech modeling, speech recognition, and speech synthesis in your course. Speech modeling, it is basically HMM or hidden Markov model is basically a programming algorithm. Once you have those features from the speech signal, how do you use them for the task of automatic speech recognition or ASR? So there is a technique for that. It's a very complicated, very powerful technique. But now things have moved on. We are now in the age of machine learning. This is also a machine learning technique, but machine learning has improved rapidly in the last 10 years due to something called neural networks or deep neural networks. So what I am thinking, I will take this HMM and then I will go through DNN in what, as much detail as the course allows, because that will be useful for your future, maybe for your even jobs and all. Particularly those who are interested, those who still want to be in technology, in the technical domain, in technology and engineering and research, you should know it will be useful for you. For those who are not interested in technology any further, maybe go for MBA or something. For them, this entire course is actually going to be quite. I'm sorry, but it might be very frustrating for you because this is going to be a very technical course. It's not going to be an easy course. So there is another course I am taking, instrumentation for an open electives. Another faculty is taking. That is a very simple course. It's good for getting grades. You will easily get grades there. So make sure to get your grades in that subject. It's really easy. So not much to do there. But this one, unless you are technically interested, not very unless you are interested in engineering, this might be a very uh, not very what is called entertaining course for you. But for those who are interested, this is a very important course, speech signal processing, and it will help you in your job interviews, technical job interviews. So that's for sure, no question about it. So ASR, automatic speech recognition, how do we do it? We have this, we break up the signal into many small packets, speech signal into many small packets or many small sounds or phonemes. And how many phonemes we take together is called anagram. Some those are small things that we'll learn. And then TT, as I said, text to speech synthesis. Somebody does not know how to read and write. He just speaks on his phone. The phone converts his speech first, his pressure signal, that acoustic signal, we call it the acoustic signal, that is converted by the microphone of the phone, of your mobile phone, into an electric signal that goes to Google's server. There is a uh, there is a machine, very powerful machine there, based on AI, capable of changing that text to speech. Once that is done, it then processes it, whatever request comes. Then, based on that request, it gets the answer. Then, once it gets the answer, it reconverts, that machine reconverts, another TTS machine is there, and back in one of the Google servers, it will reconvert it back and then send via telecommunication technology to your phone, where you will just it will play whatever the result is, play. So where is America? What is the latitude and longitude of Washington DC? Even USA, somebody just says that, all these processes will go and they will finally spell out The latitude is this, the longitude is this. So the last part, converting speech, sorry, text to speech. This is TTS technology. Here, there are certain things called intelligibility and naturalness. You must have heard in YouTube something. Sometimes people use this robots to pronounce the script what they're showing in the video. It sounds very robotic, unnatural. So the goal is how to make the machines more and more natural sounding. Also, sometimes how to change how to change if I am speaking, suppose you want to convert, for example, you must have heard these voice technologies where someone is somebody else's speech and you put it on. In fact, you could see you Messi just retired from you. I hope you know that footballer Messi. So that Messi retired from Barcelona 2 days ago. So a few 3 4 days, I think 1 week or something ago, there's a video Messi is saying in speaking in English. You type in YouTube Messi speaking in English. So it's all AI. So they are using Messi's voice characteristics, but he's speaking English. Messi never speaks in English. So this is called prosody. So somebody's voice they have taken and converted into other people's voice, and sounding natural at the same time. So this is the field of prosody. So making indirectly the target is making machines as what do you call uh, as natural sounding as possible, as human sounding as possible. So that's the aim. Regarding books, you can go through this book, Fundamentals of Speech Recognition, and the course lectures that I have that I will be giving. That should be enough. This book, go to browse through this book from time to time. I will share with you some links of lectures that will be useful. You should go through them. It will help you understand better. And then the course, all is internet is there now. The time of books is almost over. You choose a topic, go to the internet, you will get a detailed description of that article anyways. So even though we suggest books, but nowadays, and each and every particular topic you can find it in the internet. Any some document, some video will always be there. So use internet effectively, and then you should be good to go. So I hope you got the basic idea. You got the basic idea. If you have got the basic idea, type Y. Yes. So all this, there are 46 people here. So tell me frankly, are most of you interested in your future in technology, or do you want to go for MBA or other things? So those who want the technology, I just want to, yeah, tech. Just type tech. Yeah, and then those who don't want, no issue, no issue. Everybody has his uh, own domain. Some people become sports person. So many things you can do. But those who are interested in this technology, particularly speech technology, it's very high end. Let me know. I just want to see how many tech people are interested. So one, two, three, four, five, six, seven, eight. Okay, nine out of 45, only 9 or 10. Okay, so next class is from 11. I will keep this on. Next class is from 11. We will meet at 11:15 break. So, what I will do to the things that I have spoken in the previous lecture, you can get a glimpse of that. We can understand them, appreciate them better. If you go through a company profile, NTT is a very well-established company in Japan. I have shown a video from them, so I have shared the link. Go and check out that video. I will also do the same in my PC. So I hope you like the video. So uh, at least you can now appreciate what a speech technology based company does, or people domain, people working in some aspects of speech technology. What do they do? Speech or voice technology. So in the next few lectures, I will also refer you to some very useful and very wonderful lecture by University of New South Wales, Australia, Professor Ambika Raja. So I will refer you. In fact, this slide I have just taken from. It's publicly available, taken from his set of slides. He is a famous academician in speech processing, so and has very wonderful lectures available on. I think even in YouTube. I will refer to his lectures as well on top of my own lectures. But anyhow, so this is an essence of what is speech processing, the application of digital signal processing to analysis of speech signals. On top of that, I have said that we will need machine learning to be what is called at the top of our or to meet our current requirements from the programming front. From the front of, as I said, the signal processing triangle, you need mathematics, physics, and programming to be in the current level of our technology, speech processing technology or speech technology. We'll need machine learning, AI, natural language processing. Those techniques we'll need as well, on top of simple digital signal processing techniques. So, speech coding is again the same thing. You have now in a uh, simple pen drive or flash drive, you can store so many songs, or so on and so forth. MP3, MP4, all these coding formats, coding algorithms. Just like in images, you have JPEG. There's a coding or compressing algorithm. Same thing in case of audio. We have MP3 and MP4 is audio video. This kind of coding algorithms which compress and help us store speech signals in a very small amount of space, in a matter of few MBs or few megabytes. You can store 5 minute speech, 5 minutes or 10 minutes song, and so on and so forth. So speech recognition we have talked about already. Automatic speech recognition, speaker identification, and verification, they are slightly different, but it means basically the concept is to identify the speaker from his or her voice. Speech enhancement is an integral part of any of all this speech recognition, speaker verification, and so on, even speech coding, because most of the time we will have background noise, whether that be stationary or non-stationary background noise. What is stationary and what is non-stationary? Probability and statistics You probably are familiar with that, but we'll go through that nevertheless. It's a very simple concept. Then we have talked about speech synthesis. So that machine is able to convert text to speech. So you shared some videos, and we showed this triangle where signal processing lies. It's a physics, mathematics, and programming composed of all these three aspects. We get signal processing. That's why signal processing is also sometimes called applied mathematics in many foreign universities uh, in developed countries. So we have to review digital signal processing, which maybe we'll start in this lecture, towards the end of this lecture, or maybe from the next lecture. We'll review these three at least. What is an LTI system, linear time invariant system, or linear shift invariant system, Fourier transform and properties, and Z transform and properties. What I will suggest that please take whatever book you like. I will suggest that there is a whatever book you like. If you want Oppenheim, take that, or if you like that Shom's series, which is a more concise this one, you can take that and on your own browse through, go through this signals and systems concepts, because we do not have much time to cover this. I will take some lectures to brush up these things, but you will have to give your own effort also, so that you're comfortable with the subject. So let's do one thing. I will ask you, most of you are probably using Windows, but if you are also using Ubuntu, you can do that. Those who can, install this Audacity. It's a software. Audacity is a software for recording software. Okay, so I will show you how important, means why it is a very good and useful tool to visualize sounds and speech signal in general. So let me open up Audacity software. I'm using a Ubuntu system. This is Audacity. I hope you can see. If you are able to see, please type Y. Yes. You can see. No? Okay. Then good. So let's do. You can play, because it will give you a very good idea using Audacity what you will be able to do. What sounds look like, and what is their frequency spectrum look like. We'll cover some basics of DSP once again, but you have to put your effort. Those who know, we will understand very easily what I am going to show here now. So uh, in Audacity, let me record just now. I will put this record. How are you? This is a first lecture in speech signal processing at NIT Andhra Pradesh. See, I hope you are able to see. Uh, View, zoom, it to it. Okay. I hope you saw the recorded signal. Did you see? If you see, type Y. Okay. So this is the recorded signal. Now I am using a headphone, so probably will not be able to listen to it. Maybe I will remove it and then. How are you? This is a first lecture in speech signal processing at NIT Andhra Pradesh. So I hope you heard that. So let me now zoom a little bit. Maybe I will zoom this portion. View to it, something like that. I don't know what. Zoom in, zoom in. So I have zoomed in a portion of the signal. Okay. So this is from around 0.4 seconds to 1 second. So 400 millisecond to 1000 millisecond. So look at how it's this one how a speech signal looks like. I hope you are able to visualize it. Maybe I should make the screen. It does not help. So I will even zoom out even more. Let's zoom out even more. I hope you are able to see again. Anyhow, so you can see here what I was saying is, if you zoom in, it's small. It is like what, 600 milliseconds to 750 milliseconds. Only 150 milliseconds. Look at the signal. It is like a periodic signal. So these periodic signals, these are generally characteristics of vowels or vowel-like sounds. Sometimes two vowels also combine together. We call it diphthongs. When two vowels we speak together, we call it diphthong. So when you are speaking, the different speech sounds have different characteristics. You see this? You can easily see. It looks like a periodic signal, particularly the first half. It looks like a periodic signal. So again, but I will now go towards, again here there is some periodic, but because of the sound is different, it looks different. Based on the sound, there is some other characteristics. But let me, yeah. Now look at this part. This is also sound. This sound, you see, so 4280 millisecond or 4000, yeah, 4280 millisecond to around 4370. So only 90 milliseconds duration. See how this looks like. This is how a consonant looks like, generally speaking. In terms of sounds, we call them unvoiced sounds. Unvoiced sounds also have different classifications. We'll look at that. But that's why I want you to install this software, Audacity. There is another one. It's called WaveRec. You will find it. You can also install that. But in my Ubuntu system, I have been using this. That is also very easy to use. Now I will show you. We had let's see. Only this how much 80 millisecond. We'll go to analyze. We'll go to plot spectrum. Look. I hope you are able to see. This is the Fourier spectrum, magnitude spectrum. Okay. I hope you know what magnitude spectrum is, phase spectrum is, but if you don't know, we'll cover it once again. Okay, I hope you are able to see. Okay, so look how the spectrum looks like. Is the Fourier spectrum. You do Fourier transform and you get your amplitude spectrum, magnitude spectrum, and phase spectrum. Here only magnitude it is being plotted. Just look at how it is. You see, it is in a high frequency region. There is a lot of energy. Yes, in the high frequency region there is a lot of energy. Now, if I take some same same we used to look before, where is it? Yeah, somewhere around here we used to look. No, yeah, something. Yeah, here we used to look. I think yes. Let's take 600 to somewhere about 680. 600 millisecond to 680 millisecond. Let's analyze the spectrum. Look how the spectrum looks. It's very different. It's very different. So this is where uh, digital signal processing comes in the picture. Why we need to extract features for different sounds, because the speech signal, and this also changes with respect to the speaker. Every speaker has a little bit different characteristics, due to which speech is also a biometric signal. As I have said, it is an intelligence signal. It is a signal used for in military intelligence. So I hope you were able to see this. We will come to this again uh, in the classification of sounds in the first few lectures after we cover our DSP basics. When we start our speech processing course, primary speech processing course, we'll come to all this and we'll talk about different types of sounds and so on and so forth. But I wanted to show you this software so that you can play around it. There are many other things here. I think, for example, effect, noise reduction, normalize, all this you can play around. Bass and treble, what does all this thing, distortion, all this, many uh, things are there in this software. You can use it uh, and just play with it, and it will give you a good idea of uh, what are the different things you can do by simple signal processing to a speech signal. So yeah, so eh, I hope you saw. I hope most of you have Windows system and you are able to. I will again type Audacity. Just install that software. Did you get it? Yeah, install that software, and it will be very good for your own visualization purposes. You can play around with it. We will give a small assignments so that you can record your own voice. Now obviously you can do all these same things in MATLAB and all, but for lecture demonstration it is easier for me, and also as a first time user it will be easier for you. uh, this course is not it does not have the time, unfortunately, to give you uh, practical experiences in terms of coding, but that is actually quite necessary. I wish there was another semester or another course associated with it called speech technology, where we could have gone deep into or had some practical coding and programming sessions where we implement all the things that we have studied. But we will try something. Maybe I will give you a little bit MATLAB exercises, few simple MATLAB exercises that you can implement. So, so before we end this session, there is not much time left. So let's do one thing. There's another video I want you to show. Most of you are familiar with Rafale, I think, Rafale fighter jet. Yes, those who are, yeah, please. Yes, okay. Some of you are at least familiar with Rafale fighter jet. So let's see a video with speech technology. I will show you a video about F-16. F-16 is a very old jet. though there are many new variations have come, block 70 and block 80 also in process. But voice technology is very important now in defense, particularly sophisticated defense technologies, because there are too many buttons, too many things to do with your own hands. So it has become imperative that you give a voice command and the computer understands it and does it for you. You are, for example, flying an aircraft with a negative g forces and things like that, maneuvering in the air. What time do you have to to what is called scroll on your screen and do whatever you want to do, or engage with a hostile aircraft or something like that? Not much. So voice technology is incredibly important in defense. So I think I where was that? Yes. So I have shared a link. Let's check out this video. You'll understand or you'll appreciate how important speech technology is in defense. I'll also watch it from here and share the screen. Okay, so then there are only a couple of minutes left. So your I think lecture ends at 11:45. So exit the lecture by 11:45. Before that, we have 2 minutes. Let's recap. So we talked about the signal processing, what the three main things are there. Watched a few interesting videos. Went through what was your course curriculum, what we'll be going through, and there is one thing I asked you to install. Sorry, Audacity. Please install this software. You can easily record and just play around with it. You'll see what happens. Means you can visualize things. The Fourier spectrum is also there to plot. You can then you do all sorts of crazy things there and get a feel for different sounds that are there. So we'll next class we'll start with review of digital signal processing. Use OpenHAIM to revise, go through, or the SOMS series of there is a book no in for SOMS series different subjects they publish different books that is also there. You can use that. Maybe I will use that itself. For me it'll be quite concise. So please review the concepts of digital signal processing and install Audacity. uh, I will share some good lectures from University of New South Wales Professor Ambika Raja from time to time. Some old lectures but brilliant lectures. The book that you can go through is Fundamentals of Speech Recognition, but all articles are now for each and every topic are available. So many articles are available on the internet, so you can go through them as well. But this is a very good book to go through.